Welcome to Study Loop.
So here is the bent wire here that is shown in this figure. Current I goes along this and current I goes along this. We have two cases here. At a point B is 4 in G direction, and for this the B is in X axis direction, that is I hat direction, right? Okay, so the length are given, the current is given, the angle theta is also given. So let us move to the solution. So we are asked to calculate the net magnetic force on the wire, right? So let us do this turn by turn. For this wire, let us consider a point here. Okay, so let me use green here. So for this point, mm, magnetic field is along K, so it lies vertically upward, right? Vertically upward is B, and current goes along this. So if you use your right hand rule, then B is vertically upward, right? V is vertically upward, and uh, current is in this direction. So a direction perpendicular to both of these is this one, right? So this is force on this wire, right? And again, for this wire, if you again use the right hand rule for any point analogous to this point here, right? So for this point, the force will be along this. These two are symmetric, okay? So the figure will show that exactly. Now, this force has two components, one along this, one along this. Now, due to the geometry of this figure, you can say that this angle is theta. So this component of force will be F sine theta, and this component of force is F cos theta. Similarly, for this point and this force F, this will be F cos theta, and here this will be F sine theta. So for every such points in these two wires, these forces on this direction minus x and plus x directions cancel out each other, and the forces on the minus of y-axis add up, right? So the total force acting on these wires, F net, can be written as twice of F cos theta, right? Now in which direction? Downwards, so minus j hat direction. Right, now what is the force on one wire? So force on one wire is B magnetic field I L sine phi, where phi is the angle between length and B, or the direction of current and B. And then let me continue this equation, cos theta minus j. Now what is B? B is given in the question 4 times. Magnitude of B is 4. Magnitude of current is 2 amperes. Length is 2 meters. And what is the angle between B and L? So B is vertically upwards and length is on xy plane, so 90 degrees. So sine 90 is 1. I don't need to write anything. And cos of theta is given 60 degree. So cos 60 is 1 by 2. 4 to the 8, it is a 16. So F net is equal to minus 16 in direction of j hat. So this is the net force. Alright, so we are done with this part of the question. Now let's move on to the second one. It says now the magnetic field is along x. So this is the direction of B. Right? Now look at the figure here. B and I both lie in xy plane. Right? Both lie in xy plane. So the cross product of I and B, when we calculate that force, that is F is equal to IL cross B. If you calculate this force, then the force should lie on the on the direction perpendicular to both B and I. Therefore, it lies along J or along G. Now, for the first wire, if you use the right hand rule, then force lies along minus K, that is downwards. Into the paper or into the screen. Whereas for the second wire, F lies upwards by using right hand rule, that is in K hat direction. So for every points in this wire, there is a point which has force in opposite direction, right? So all the forces on these wires, so force on this point and force on this point are equal and opposite. Force on this point and force on this point are equal and opposite. So every forces at every points cancel out each other and the net force becomes 0. So the net force on the wire will be 0 when the magnetic field is along x-axis. So we are done with part B of the question as well. So this ends the solution for this question. Thank you so much for watching.